Alright, so this is number 23, and it's asking us to determine whether this geometric series converges or diverges, and if it does converge, what does it converge to? So I went ahead and wrote down the formula in yellow here for a geometric series. Basically, for it to converge, we have to have the ratio between the terms to be strictly less than 1, and if it were to diverge, it would have to be greater than 1. And then this is the version where we're starting at n equals 1, and you can see that it has n minus 1 in the exponent. But you could also write it like this, equivalently, n equals 0 to infinity. A to the r n equals a 1 minus r, with the same conditions on r. And basically it's just this, it's the exact same thing, because if you look at n equals 0, the first term is just going to be a. And if you look at this one, when you plug in 1, the first term is r to the 1 minus 1, which is 1, and then times a. So you also get a. So it's basically just the first term over 1 minus the ratio. It doesn't matter if you start at 0 or 1. You just have to be careful to include the first term here, and that's it. So in this case, we start at n equals 1, so this is the appropriate form we're going to look at. And we're really just trying to get this exponent to match this one, so we can put it all as the ratio. So to do that, let me just start off by writing the series down. We can start by, the top is fine as is, because it is raised to the appropriate power, but we want to get the bottom to match. And the way we can get that to be n minus 1 for the 4n is just factor out a 4 as such. And then that's an equivalent statement, because 4 to the 1 times 4 to the n minus 1, if you add the exponents, is just 4 to the n, which is what we started with. So it's just a different way of writing it. And then from there, what we can do, well, we can factor out that 1/4, that's not a big deal. And then the numerator and the denominator here are both raised to the n minus 1. So we can write it like that. Again, equivalent, just writing it into the form that we know how to deal with. And then from here, we can see that our ratio is -3/4. And -3/4 is an absolute value strictly less than 1. So this series is convergent. And then from there, we just apply the formula. A 1 minus r. So our a is just this thing here hanging out as in the formula, our first term, because if we plugged in 1 here, it would just go to 0. And then 1 minus, now careful here, our ratio is -3/4. So we do have to include that. The absolute value is just checking for the absolute value, I guess. So 1/4, and then combining these two terms is 7/4. And then from there, simplifying that, you'd get 1/7. And that would be what it converges to, what this series converges to. In the next example, we're going to work one out where it diverges.